Today we're working on 2.2, the algebra of functions. We're going to first look at an example where we'll add two functions together, subtract two functions, multiply, and divide. So our first one here, we've got given f of x equals 2x plus 3 and g of x equals 1 minus x squared. Find part A, f plus g of 3. Okay, well this is function notation, so it's telling you that they want you to plug a 3 into both of these two functions and then add them together. Okay, so you can rewrite this as f of 3 plus g of 3. And that shows exactly what you're doing. You're going to plug 3 in for x in the g function and 3 in for x in the g function. Did I say f function? I meant to say f function when I pointed at that one. Okay, so let's go ahead and do that. So we'll plug 3 in for x here. So we've got 2 times 3 minus 3, and then plus, plug 3 in for x for the g function, so 1 minus 3 squared. And then follow your order of operations and simplify. So we've got 6 minus 3 plus 1 minus 9. So we've got 3 plus 1 minus 9. So I'll give us 4 minus 9, so a negative 5. So we'll just do a couple more so that you can see all of the different kinds of operations. So part B, they want us to find f minus g of negative 1. So again, we can rewrite it, f of negative 1 minus g of negative 1. And I'm using the same functions. Okay, so this is f and this is g. So we're just plugging negative 1 into the f function, and we're plugging negative 1 into the g function. So we've got 2 times negative 1 minus 3. Minus, be careful when there's a minus sign because we want to subtract all of this. So it's best if you put parentheses after your minus sign here. And then we'll plug negative 1 in for x. So we've got 1 minus negative 1 squared. And use order of operations and simplify. So we've got negative 2 minus 3 minus, I'm going to take away the parentheses after I simplify everything. So that's going to give me a positive 1. So 1 minus 1 is 0. So we've got a negative 5 here. Okay, notice you do want to keep the functions in the order that you see it in the problem. They gave me the f first and then subtracted the g. So you want to keep them in the order that you see them, especially for subtraction and division. Of course, the order is going to matter. So pay attention to what the order is in the problem. Okay, let's try a couple more. Part C. I've got f times g of 0. Okay, and remember, this is function notation, so they're telling you to plug in the 0. Whatever's inside the parentheses here, you're plugging it in. Okay, so this does not mean multiply. Some people just put the answer 0, but no, you're plugging in the 0, and we'll see what we get. So again, we can rewrite it, f of 0 times g of 0. Okay, so we'll plug 0 in for x. 2 times 0 minus 3. And we're multiplying these, so I'm going to go ahead and put this all in parentheses so I can show that I'm multiplying this whole thing times whatever we get when we plug 0 in for g. So 1 minus 0 squared. So here we've got negative 3. And in this parentheses, we've just got 1. So negative 3 times 1 is negative 3. Okay, and finally, we'll make sure that we do an example of division. So in part D, I've got f divided by g of 2. Okay, and again, I'm going to rewrite it. So this just means we're taking f of 2 and we're dividing it by g of 2. Okay, so we'll go ahead and we'll plug in that 2 in for x in both of our functions. So I've got 2 times 2 minus 3 all over 1 minus 2 squared. Okay, so on top we've got 4 minus 3, which is 1. On bottom we've got 1 minus 4, so that's negative 3. So I get a negative 1/3 for my answer. Okay, so we've done one example of each type of operation. Okay, so let's go ahead. I want to do one more because sometimes they have you use the same function more than once. So I'm going to do f plus f of 1. Okay, but you're still doing the same thing. You're just going to use the f function twice. So I'm going to rewrite it. F of 1 plus f of 1. And we're just plugging 1 in for x, and we're just using our f function this time. So we've got 2 times 1 minus 3 plus 2 times 1 minus 3, and then go ahead and simplify. So we've got 2 minus 3 plus 2 minus 3. So we get negative 1 plus negative 1, which gives us a negative 2. Okay, so in this first example, they gave us something to plug in. But sometimes they just want us to do the operations on functions and not plug anything in. Just simplify as much as you can. So let's take a look at some of those examples. Okay, so I've got f of x equals 2x and g of x equals x squared. And in part A, they want us to find f plus g of x. Okay, well for these, they normally ask you to find the domain as well. So whenever they ask you to find the domain of these, it's best to find the domain of what you start with first, because your domain can never get bigger than what you started with. So you do want to see what you have to begin with. Okay, well remember, when you're asking yourself what is the domain, you're asking yourself, what can I plug in for x and still get a real number back out? Well, we can plug anything in for x here and we'll still get a real number back out. So the domain is all real numbers here. Same thing for this one, which is great because if we start with all real numbers, we know we can't get any bigger than that. But just so that you know, for future courses, you should always check the domain you start with first because your domain cannot grow. Okay, so let's go ahead and do what the first one tells us. We're adding the two functions together. So again, you can rewrite it. This just means we're doing f of x plus g of x. And then we're doing exactly that. We're adding the two functions together. So f of x is 2x plus g of x is x squared. And then if you have any like terms, add them together. Here there's no like terms, so we'll just leave our answer as is. And the domain of this, all real numbers. Okay, well, we'll just do one of each again. So let's do f minus g of x. That means we're just taking f of x minus g of x. F of x is 2x. G of x is x squared. Again, they're not like terms, so we're finished. And the domain is all real numbers. Part C, they just want us to multiply them together. So f times g of x. So we're taking f of x times g of x. So we've got 2x times x squared. Remember, when you have the same base and you're multiplying, you're just adding your exponents. So remember, there's a 1 here, so we've got 2x cubed. And again, our domain is all real numbers. Okay, and then finally for part D, I've got f divided by g of x. So I'm doing f of x divided by g of x. Okay, and in my examples, they put f on top, they put g on bottom. But again, in your homework, be careful. See what order they put it in, because order does matter. Okay, so I've got 2x over x squared. And we can do a little bit of simplifying here. We can cancel an x off the top and the bottom. So we get 2 over x. The domain is not all real numbers this time, right? We can't have 0 in the denominator. That makes it undefined. So the domain for this one's all real numbers except 0. Okay, so the last thing in this section that they want you to take a look at is called the difference quotient. And if you take calculus, you'll see this more. In this class, we're going to just take a look at the algebra behind the difference quotient. But if you take calculus, you'll see what it's used for. Okay, so their difference quotient is f of x plus h minus f of x, all divided by h. Okay, and you can break it up into 3 pieces, or you can do it all at once. I'm going to go ahead and just do it all at once. We're only going to be working with linear functions when we're doing the difference quotient in this class, so it won't get too complicated for you. It's just so that you have a chance to use it. So example 3, they give us f of x equals 2x minus 7, and they want us to use the difference quotient. So let's go ahead and do what the difference quotient is telling us here. So if you look at the formula, it's telling you that it wants you to plug in x plus h into your f function. Okay, so the first thing we want to do, let me just write down the difference quotient again. Okay, so the first thing we want to do is plug x plus h in for x right here. So we've got 2 times x plus h minus 7 And then the next part of the formula says subtract. Okay, well, whenever I see subtract and we're subtracting a whole function after that, I want to put parentheses because I want to make sure I subtract the whole thing. And then it says subtract f of x. Well, that's what they gave us, 2x minus 7. And then all over h. Okay, so here I just did what the formula told me to do. And then after that, all you need to do is you're simplifying. So I'm going to distribute the 2x plus 2h minus 7 minus, I'm going to distribute the negative here, so 2x plus 7 all over h. Okay, you should see some stuff canceling out. We've got a positive 2x and a negative 2x. We've got a negative 7 and a positive 7. So we're just left with 2h over h, and then the h's cancel. So our answer is 2. And that's it for the examples for this section.